All right, guys, welcome back. So we're going to do a construction lesson. Now, if you do not have a compass, and here is, this is the normal version of a compass, okay? If you don't have that, that's okay. Still watch this video. I do have an exit slip that you will see here shortly, okay? And it's pretty much just, as long as you watch the video, you could do the exit slip, no problem. Okay, but if you do have a compass, then follow along. Okay, I like doing stuff like this. It's a fun lesson for me. So first things first, parts of a compass. You ready? Okay, actually, that's the teacher version. Let me give you the normal version. So parts of a compass. Here we go. This end hurts. This end draws. That's it. Okay, there's your parts of a compass. Okay. In seriousness, though, the one thing you want to note, and as you can see, we're going to be drawing a lot of circles with this, okay? Arcs, angles, all kinds of stuff. But you can see that this has that nice little circle mentality to it. So the distance between the pencil and the tip, we call it the radius, rightly so. So anytime if you hear instructions saying, hey, adjust your radius, you're literally adjusting the distance between the pencil and the tip. Now, one thing that when I'm working with these, and one thing that helps me, make sure that the pencil and the tip are roughly at the same height like this. And there's a nice knob here that you can twist so you can tighten and loosen this pencil, okay? Now, when you're using this, I would highly recommend not to do this, okay? So for instance, if I'm on a piece of paper and I'm drawing a circle, don't draw it like this, okay? The reason why is because you're going to loosen this pencil, okay? You're going to continue to move that knob. And when you're using both hands like this, you're going to be changing the radius as you're doing it, okay? My recommendation would be to hold it up here at the top, okay, and just use your fingers to turn it as you're making your circle. The other thing that some people do is they'll put this on paper and they'll turn the paper so that way it makes the circle. And when you do that, if you actually turn it at a nice angle, like a 45-degree angle, you're reducing the amount of friction that the compass is putting on the paper, and it's easier to work around. So just a couple little tips to help you create some of this stuff. So today we're going to do concentric circles. We're also going to be copying a line segment, copying an angle, bisecting an angle, and I'm going to show you how to create an isosceles triangle. A lot of stuff to cover here, so let's just get right into it. So the first thing is, if you're going to make a concentric circle, okay, you need a center point, just like that, okay? I know you can't see it that well, but there it is. So then you're going to take your compass and start off with a small circle. So you're going to put the tip here, your pencil on the outside, and you're going to draw your first circle, just like this. Okay, mine's not going to look the greatest. I actually need a new compass. This one is losing suction. It doesn't stay up too well. As you can see, it doesn't stay up too well, okay? The other constructions will go a lot better. So what you're going to do, once you get your first circle made, you're going to go ahead and just make this slightly bigger, the radius, okay? You're going to use the same center point, and you're going to draw another circle outside of this guy. Just like that. That one wasn't too bad. I'll give myself some credit for that one, okay? So, what are these guys called? I can make another circle and another circle, but they all have the same center point, right? These are called concentric circles, and it kind of reminds you like if a water droplet went to a pond and it ripples outward, or a dartboard, okay, a target. But that's what concentric circles are. The radius is always changing, okay? As you go further outward, the radius of the circle gets bigger. So that isn't consistent. The only thing that is it has the same center point, okay? So that's concentric circles there. All right. So, drawing a circle, not too bad. Okay, next thing we're going to do is we're going to copy a line segment, okay? So for your first step, you're going to draw a small enough line segment there. Then you're going to draw a larger one here at the bottom. Just like that, okay? Label this A. Label this B. And I'm going to label some point down here C. Just like that. Now the goal is I'm going to copy the length of this guy down to here. Now you can probably see how we're going to do that. This one isn't a difficult one. So remember, this is a nice fixed distance. That's the word I want to use. So you're going to put the tip where A is, and then put your pencil where B is to measure that distance. Now what some people will do, and I recommend it as well, you can put an arc right here. You see how I'm doing that? That's just like an accuracy thing, just to make sure that this pencil is on that point. Okay, and as you can see, it is. Now, keeping this as the same distance, I'm going to go where C is. I'm going to put the tip there. I'm going to draw an arc right here that crosses this line. Okay. Now that is doing two things. One, it's copying the distance down to here. But two, technically, any point I put on this line is going to be the same distance to point C. So it does two things for you. Okay. Put a dot right here where it intersects. We'll put D. And we're done. This is now the same length as this guy. Okay? And keep the arc there. It's, like I said, it's an accuracy thing. If you're actually designing things and you want a finished product, yeah, you would probably erase that. But like I said, that's like an accuracy mark. Okay? So that's copying a line segment. Let's keep going. Since we're copying a line segment, let's copy an angle next, right? So we're going to start with an acute angle. Any measurement, doesn't matter. And I'm going to put a line down here. Just like before, I'll put A. There we go. Okay, just like that. And all for the heck of it, we'll call this vertex D. We'll have some labeling involved. So my goal is to take this this angle and recreate it down here. Same measurement using nothing but a compass. And here's what we're going to do. This is how we're going to do it. Okay. First off, and you're going to have to adjust this a couple times just to let you know. I'm going to start here at vertex D. And all I'm going to do, just to size things up a bit, I'm going to draw an arc that cuts through both sides of the angle just like that. Okay. Now, once I have that in place, I'm going to come down here to A. I'm going to put my tip of the compass down here. And I'm just going to draw a nice little arc. And I'm going to make it a little bit bigger than usual. Okay. And I'm going to go ahead and mark this guy off. You could say in a way I copied this length down here, but that doesn't really matter. It's just a nice little reference point. And we're going to mark this guy, and we'll call this B, point B. Now, somehow, I got to get this top part of the angle down here at the exact measurement. So to do that, you see where this arc intersect both sides? And if you want to, sometimes it helps, you could put points there so you have more of an accuracy thing. So you're going to have to adjust this a little bit. So you're going to put the tip right here at the first intersection point, and you're going to adjust your radius to where it hits the second point right up here, and you're going to draw an arc. Once again, the arc is only there to indicate that you're on that spot. Okay? So just like that. Told you I need a new one. The suction cup is like not staying onto this thing. So what I just did is I copied this guy right here. The width of that angle is right here. Now to translate it, I'm going to come down here. Where that intersection was, I'm going to put my compass at this point, and I'm going to draw an arc that crosses the first arc right up here. Okay, just like that. Okay. I'm going to put a dot right there at the intersection. Not a dot, a point. Got to use the right language. And what I'm going to do is I'm going to connect the vertex A to that point as best as I can. Okay? And I'm done. So now this measurement is the same as this guy without using a protractor. Okay? So technically, just to show you, what we did, the reason why I drew the first arc was because the next arc can help me figure out the width of the angle. So this is really all you were doing. You were measuring how wide this angle is using nothing but the compass. So there we go. We copied an angle. Okay. All right, next up, let's bisect an angle. Okay, and how are we doing? Oh, we're doing pretty good on time. So we'll draw another cute angle. Why not? And let's label this vertex A. Oh, just like that. And bisect means I'm going to cut this angle in half. Okay? So think about how we're going to do that visually. If I'm going to cut this thing in half, I have to find a point that's somewhere out here in the middle. Once I find this middle point, I'm going to connect the vertex to that point, and it's going to cut the angle in half. So I'm going to find the middle here in this interior region. So how am I going to do that? Well, first off, you don't want to make this too big of a radius. What I'm going to do is I'm going to start where vertex A is, and I'm going to draw an arc that goes through both sides of the angle, just like that. Okay? I'm going to put points at each intersection, and I'll name them. We do have to name every point, technically not, but just for the video, for the sake of it. Now, you want to keep the same radius. If by chance on your paper you're like, oh, I'm running out of space, I mean, you could shorten this, that's fine. Just make sure it stays consistent for both arcs you're about to draw. So what you're going to do is you're going to stick where C is. You're going to put your tip there, and you're going to draw an arc big enough to go right in the middle of the angle. Because once again, I'm trying to find where's that middle point at so I can bisect the angle. Keeping the same radius, go where B is, and you're going to draw an arc again that comes all the way down, okay, and it crosses the other guy. Where they both cross, you're going to put a point at that intersection. That point represents the middle of this space. That's what we just found. And why is that the middle? Well, look at the compass for a second. This is a fixed distance, right? We find a distance that is the same from C and the same from B, okay? And both of these are reaching out towards the center of this angle. So you got to keep that in mind. This is a fixed distance. All right, last step, connect them. So where the vertex is, and I'm going to do the best I can, guys. Where the vertex is to that point, you're going to draw a line. Just like that. Honestly, and looking at my video, I don't think that's too bad. I'm quite proud of myself. I'm very good at a regular protractor, can't talk. I'm really good at a regular compass. The teacher version for the board, I'm still practicing on, to be honest. It's a little bit more difficult. Okay? So if this whole angle was 40, that's 20, and that's 20. Okay? So, last thing we're going to do is we're going to create an isosceles triangle. Okay? So how are we going to do that? Well, first off, we're going to have the base. Just like this. I'll label it A and B. Okay? All right. Now, how am I going to do this? Well, remember, this thing draws circles, right? They can draw congruent circles, which means they're the same. And congruent circles have the same radius, right? So let's try and find the intersection of two circles. And that intersection is going to be where both radiuses collide. Okay? So let's do that. So the first thing I'm going to do is I'm going to start where A is. I'm going to go where B is. I'm going to draw a circle, just like this. Now, what I'm going to do is I'm just going to draw half a circle, okay? Or, you know what? No, I'm going to do the full circle. I'm going to do the full circle. I was only going to do half because this doesn't do well. It keeps loosening up. But I'm quite proud of that circle. That was pretty good. All right, we're going to switch it. So now we're going to flip it. we're going to put the point where B is, the pencil where A is, and we're going to draw another circle. Ah, see what I mean? It came. Oh no, came undone. That's okay. There we go. To be honest, I'm quite proud of that still. That's not too bad. Okay, so both of these circles are the same. They have the same radius because we didn't change this guy. So look at where they intersect, right up here. Okay, that's their point of intersection. Now note something. Look at just this circle. The center of this circle, if I draw a radius from here to here, it's the same length as this circle, and if I drew a radius from here to here. Since both radii are the same length, we have an isosceles triangle. Isosceles means two congruent sides, so we figured it out. So here is what that looks like. Just connect them. Just like that. Okay? So this is my isosceles triangle. Both of these guys are congruent because they're the same circle with the same radius. Which that's really cool. Okay? What you could do, like I said, you don't need the full circle. You only need, technically, that part, right? You only need where those two arcs intersect. But I still get people who draw the full circle and then they mark the intersection. But really, you just need where those two arcs intersect. So there's my isosceles triangle, which is pretty cool. Okay. I will upload online my construction activity. It's a packet. Once again, if you have a compass, try it out. Okay. If you don't have a compass, that's okay. Still watch this video and just complete the exit ticket afterwards. Okay, because I ask a couple questions on that. Other than that, that's it, guys. So, hey, hope you're doing well. Hope you're enjoying your day, and I will see you guys in the next lesson. Take care.